We need to prove the following. Will you be using the De Moivre's theorem, which states that whenever we have cosine of theta plus iota times sine theta whole raised to the power of n, so that's given by cosine of n theta plus iota times sine of n theta. Now let's begin. So what we'll do, we'll try to simplify the numerator and the denominator separately. So here we will begin with the portion 1 minus cosine theta plus iota times sine theta. Now what we'll do here, we'll try to make this negative to positive by using the fact that cosine of pi minus theta, so that's equals to negative cosine theta, and sine of pi minus theta, that's equals to positive sine theta, which means we will have 1 plus cosine of pi minus theta plus iota times sine of pi minus theta. The reason why we're doing this, so that we can apply the half angle formula to the first two terms. The half angle formula states that whenever we have 1 plus cosine theta, that's equals to 2 times cosine squared theta over 2. We'll be also applying the half angle formula to sine pi minus theta. So the half angle formula for sine theta states that we have 2 times sine theta over 2 times cosine of theta over 2. This will now give us 2 times cosine squared pi over 2 minus theta over 2 plus iota times, so sine pi over minus 2 will be 2 times sine pi over 2 minus theta over 2 multiplied to cosine of pi over 2 minus theta over 2. Now from the first term and the second term, we can take 2 cosine of pi over 2 minus theta over 2 as the common factor, such that this gets now multiplied to, from the first term we are left with cosine of pi over 2 minus theta over 2 plus iota times, and from the second term we are left with sine of pi over 2 minus theta over 2. Right, now what we'll do, we'll raise both sides to the power of n. So we have 1 minus cosine theta plus iota times sine theta whole raised to the power of n. This is going to give us 2 raised to the power of n times cosine raised to the power of n of pi over 2 minus theta over 2. And this entire expression, so let's write it down, cosine of pi over 2 minus theta over 2 plus iota times sine of pi over 2 minus theta over 2 whole raised to the power of n. So we are going to label this as number 1. We'll keep it aside. What we'll do next, we'll tackle with the denominator portion, which is 1 minus cosine theta minus iota times sine theta. Now if we use the same approach, 1 minus cosine theta minus iota times sine theta, so this will be equals to 2 times cosine of pi over 2 minus theta over 2. That will get multiplied to cosine of pi over 2 minus theta. This is going to be exactly like this particular expression, except for the fact we have a negative sign here. Well, negative iota times sine of pi over 2 minus theta over 2. Now before raising to the power of n, we'll have to do a little bit of algebra of manipulation for the terms inside the parentheses. So here we can rewrite it as 2 times this will remain the same, 2 times cosine of pi over 2 minus theta over 2. This will get multiplied to cosine of, so we will multiply to negative of pi over 2 minus theta over 2, and we'll absorb this negative sign as plus iota times sine of negative of pi over 2 minus theta over 2. Now this can be done using the fact that sine and cosine are odd and even function. That means if we have sine of negative theta, that's equals to negative sine theta, because sine is an odd function. Cosine of negative theta, that's equals to positive cosine theta, because cosine is an even function. So this is positive, so we have written in terms of cosine of negative theta, and this negative of sine theta is written as sine of negative theta. The whole idea of doing this is now we'll be applying the De Moivre's theorem, this can be rewritten as equals to 2 times cosine of pi over 2 minus theta over 2 multiplied to cosine of pi over 2 minus theta over 2 plus iota times sine of pi over 2 minus theta over 2 whole raised to the power of negative 1. Now we will raise both sides to the power of n. So it's that we have 1 minus cosine of theta minus iota times sine theta whole raised to the power of n, such that this will be equals to 2 raised to the power of n times cosine raised to the power of n of pi over 2 minus theta over 2 multiplied to cosine of pi over 2 minus theta over 2 plus iota times sine of pi over 2 minus theta over 2 whole raised to the power of negative n. Now we'll label this as number 2. So we have obtained equation number 1 and equation number 2. So this is equation number 1. We'll divide equation number 1 with equation number 2, and this is going to give us, now we can factor out 2 raised to the power of n from both the numerator and the denominator. Similarly, we can also factor out cosine of raised to the power of n of pi over 2 minus theta over 2 from both the numerator and the denominator. Then we can combine the two expression in the numerator and the denominator as cosine of pi over 2 minus theta over 2 plus iota times sine of pi over 2 minus theta over 2. This entire expression will now be raised with, so we already have n in the numerator as the power of the numerator, and the negative n, which is the power of the denominator, gets added to it to become n plus n, or simply this will be equals to 2n. Now we can successfully apply the De Moivre's theorem. So we'll have cosine of 2n multiplied to pi over 2 minus theta over 2 plus iota times sine of 2 pi multiplied to pi over 2n times pi over 2 minus theta over 2, which is going to give us cosine of n pi minus n theta plus iota times sine of n pi minus n theta. So this is what we needed to show. So let's go to a question. Yeah, so we have successfully shown that our given expression becomes equals to cosine of n pi minus n theta plus iota times sine of n pi minus n theta.